Hi. I have been busy for the last month, and mainly because I was playing with the latest addition to the lab, an Ender 3 3D printer. I have been interested in getting a 3D printer for a long time, but never seemed to be able to justify getting one, because historically, I am talking about years back, they were quite expensive, and the lower-end ones were just not that great. But over the years, the prices of these 3D printers have gone down dramatically, and the print quality has become so consistent that even a cheap 3D printer nowadays can yield quite satisfactory print results. Anyway, the Ender 3 is quite affordable, coming in at roughly $180 depending on where you purchased it. And although it is a kit, it is quite easy to assemble together, and for electronics hobbyists like you and I, putting it together should be quite trivial and not a problem at all. I think it took just under an hour for me to put everything together properly. Now, before I bought this, I combed through the internet and also consulted quite a few gurus on which 3D printer to get. And the response I got is pretty much unanimous on this Ender 3. And I can tell you after using it for nearly a month, I can certainly say that you can't go wrong with this as your first 3D printer. Given its size and capabilities, you can print some quite complex stuff using materials like PLA, ABS, and even nylon. And the best thing is that the parts for this printer is readily available and quite inexpensive, which means the long-term ownership cost should not be a problem either. And there is a large community dedicated to this printer for the hardware and the firmware, so you wouldn't be left alone should you encounter some problems. Anyway, as you can see, my setup here, it fits in this tight spot on my desk next to my workbench. And the shelf here is not tall enough for me to put the spool holder on top of the printer, as you typically would do. But I was able to mount the holder onto the underside of the panel back there, and it worked quite well. The angle is a bit off, but the side benefit is that the filament stays away from the Z-axis. There are quite a few 3D printable mods available, and you can go to town on it if you really want to, but for me, I just made a couple. The first thing actually is very easy, is this connector clip on this Bowden tube, as you can see here. So I made two, one for the bottom, and the other for the top portion, which you cannot see, but is quite comparable to the one I'm holding here. So one of the common problems of this connector is that while the 3D printer is in motion, when the filament is being fed, the connector somehow wiggles back and forth, and that affects the print quality. And so you can print this little clip to place it in place so that when it's printing, the connector doesn't move, and it had worked out quite well. And another modification I did is this fan cover, which I will show you just right here. And the one I used is actually a very simple one. I found this on Thingiverse, and it's just a clip-on cover, which is quite nice. It does not require you to remove the screws and change for a long screw to hold it down in place. It's simply just put right over the hole in the middle of the fan, which works out really well. It's not the most secure because you can wiggle it quite a bit, but it nevertheless is quite useful. And for controlling the Ender 3, I opted to using Octopi on a Raspberry Pi. Although I could have just used the included SD card for transferring my print files to the 3D printer from the computer, it is a lot easier to operate remotely from a computer, and the Octopi does a great job doing that. The Raspberry Pi I used is the first generation B model. I had one lying around and thought it would finally be a good place to put it into use. I don't mind having to hardwire the Pi with Ethernet cable, as the switch is just sitting above the shelf and it's very convenient for the wiring. The only drawback though is, for this model at least, is that it takes forever to boot. You really have to be patient. I timed it once, and I think it took more than 5 minutes from the time the power is supplied until I was able to access the web server. But besides that, once it is booted, everything works quite nicely. I also didn't bother hooking up a webcam to remotely monitor the progress of the 3D print at the moment, but it is something that I can do later if I find it necessary. So now with this rather long intro to the Ender 3 3D printer, let's go back to the workbench to see exactly what I was trying to do for this video. If you recall, I have a Bertem 225-20R high voltage power supply, which can supply a modest 1 milliamp current at a voltage up to 20 kilovolts. And I'm planning to do some experiments with it in the next couple months. This Bertem 225 power supply comes with this particular high voltage output connector, which I couldn't really find any information on it. One of my viewers suggested that it might be a CMC series connectors made by Connectronics, but I did not investigate much further. Plus, it would be very expensive to get a proper connector and a cable because these are very low volume connectors, so it would cost a fortune. So here is what I did in Tinkercad, and as a beginner, I'm sure there are many software that you can use to create your 3D model, but I think Tinkercad is actually really easy to get started, at least for me. All you need to do is to sign up for an account, which is free, and then you can start tinkering. And so the idea of all the shapes are kind of, you can add them together and subtract one shape from another to form the shapes that is desired. And anyway, so here, as you can see, that's the final connector that I have. I deliberately left this as a kind of a ridged instead of having a very smooth outer surface, because you can actually use your hand to twist and securely hold it. So anyway, so let's take a look at this shape in detail. And as you can see, the construction of this mostly is made of cylinders and either adding or subtracting them together. And the most difficult part perhaps is this thread inside, because this I don't have any information on this specific connector. I had to kind of measure it and just guess what the specification is. But of course, I will leave the file for you guys to download if you guys want to print out a similar connector, and you can kind of take a look at all the parameters here. Anyway, for this connector, let's actually change it to a different view so you can see what it is. It's actually a little bit more complicated here. So you can see, let's zoom in here, that the inside actually has quite a few sections. The idea here is this little section here that you can see that is tighter than the hole on the top or at the bottom. This is because I wanted to use that to hold a piece of magnet wire as the center connector. And without that, because of the connecting opening here is relatively large, then what happens is that this wire is going to be wiggling around. You won't be able to secure it. And at the other end here, you can see a slightly bigger opening. This is because I wanted to use this section to insert the high voltage wire into it securely and probably glue the side to the wall here so that it can be securely held. And so that's kind of what went into the consideration. And originally I wanted to print out something that kind of like a strain relief, but since the PLA is extremely hard and actually it doesn't work out that way, so I just left it the easiest way possible. And so that's pretty much what this is in this design here. So let's now hop over to the exported STL. So basically, to print this, I actually used another piece of software called Cura. By the way, all these software are not open source, but are freely available, so you can use them and on the platform of your choice. I happen to use Linux, and both Tinkercad, of course, is a web-based software, and the Cura is actually coming. You can install it onto your Linux distribution. So after I import the model into Cura, you can see it's right here. And by the way, this one does not need any support. This actually slope prints out very nicely with the 3D printer I have here. And as you can see, this is more or less the same model, but we can expand this to do a layered view, and we can see during printing what is being printed on each layer. So you can see that we can kind of rotate it, and you can see this is the bottom layer, and we can keep building up, and there are some fillers in the middle. And now we print out this nice connector here. So after I'm satisfied with this, I basically selected the parameters. I wanted to print as fine as possible because we have the threads here. My concern was that the threads were not able to be printed correctly or accurately enough to work. So I chose the finest, which is also the slowest layer height, which is at 0.1 millimeter. And so the print speed is really slow. And I left the infill as 20%, which is good enough for most of the prints. So this print, believe it or not, it takes about 2 hours, actually more than 2 hours to print due to the layer height here. But I'm sure if you were to use a higher tolerance, you can probably, lower tolerance rather, so the higher layer height, you can probably get it done within an hour. But that's what I did here. So let's take a look at the printing and also hop back to the workbench and see the final result. And here is the printed product. And by the way, it took me actually quite a few prints to get this exactly the shape and the dimension that I wanted. The main issue here is that the diameter is a little bit touchy. And if it's a 0.5 millimeter too small, you won't be able to put it on. 0.5 millimeter too large, it is going to be wobbly. So as you can see, I actually printed quite a few here. And these ones are the ones slightly off and didn't quite work out. But that's the one thing of 3D printing. And of course, after I gain enough experience, I'm sure I'll get better at it. By the way, before I actually came up with this design, I printed one like this. So this one, you can see it's actually similar to what I had before. But since the PLAs are not flexible, and I think there's no use for me to have this section right here, and so I just chose instead to kind of gradually taper this off and made it this way so that I can print faster. Also, it's functionally equivalent. And my plan is to, by the way, right now I'm waiting on some high voltage wire to arrive. And my plan is to do exactly the same as this one here. So to use a piece of magnetic wire, like this one, for example, and solder the high voltage wire to the end and insert this through this tight, by the way, you can see here, this is what I mentioned before. The hole inside, as you can see, is much smaller than the hole that I put into this high voltage connector. But to insert this in and solder the high voltage wire at the end, and we should be good to go. So let me screw this on and just see how nice a fit it is. And by the way, you can see that this ring essentially goes over the center rubber piece of the connector here, and basically stays between the middle layer and the inner layer. So let's give it a shot, and let's Start screwing it in, and actually you can see that the fit is relatively nice, and now it's securely connected. So I think this one definitely is a upgrade to my original high voltage connector, the makeshift one here. Anyway, I hope you enjoyed the video. After I get my high voltage wire here, and I'm going to finish this connector, and I will show you guys again. But I hope you enjoyed the video and learned something new. If you liked the video, please give it a big thumbs up, and remember to subscribe, share, and I will catch up with you next time.